Hello guys, I've made this video about ionic equations. If you have any problems around this topic, so I've actually summarized it in so much more simpler words. Okay, so why we want to know that first of all why we actually do ionic equations. So when a strong electrocytes dissolve in water, they exist predominantly as ions rather than molecules. So that's why we write these compounds as ions rather than in complete chemical formulas. Okay, as you see in my definition, you come across electrocyte. So I've put a definition for that. Electrocyte means a substance that conducts electric current as a result of dissociation into the ions. So we can have an interesting example of electrocyte in our cell membranes, which is really interesting. Okay. Well, before I tell you how to do the ionic equation, first we have to get ourselves familiar with different equation. First of all is a word equation, which I'm sure you are familiar with, which is simply writing the compounds together. Like I use this example. Copper sulfate plus sodium hydroxide gives you sodium sulfate plus copper hydroxide. This is the word equation, and if I want to write it in balanced symbol equation, all I need to know is that I have to refer to periodic table of elements to know actually the symbol of each element from the table and write them down in this equation. So which will have CuSO4 aqueous plus 2NaOH. Aqueous gives you Na2SO4 aqueous plus CuOH2 solid. Well, so you might notice how we have actually identified the state, which I will explain it in the second step. The second step is to complete the ionic equation. Okay, how? We have to deal with two things to do that. First, we have to separate any soluble strong electrocytes into ions. We can determine this by referring to table of solubility guideline. So what it means basically, so as you see, I'll get my pointer. Okay, as you see in this balanced symbol equation, what all I need to do is to separate these electrocytes into the ions. Okay, so to do that, the ones it says we have to refer to a table of solubility guideline to do that. Okay. And okay, so basically that means we want to know which one of these are actually soluble and which one not soluble. So when they are soluble, we can separate them, and when they're not soluble, like this, we cannot separate it. Okay, as you see in this example, I've put it down, the complete ionic equation. I've put aqueous for all that. I could separate them unless the CuOH2 or copper hydroxide. Okay, I will show this copper hydroxide in the table of solubility guidelines, that how this is a solid, and that means not soluble. Okay, by looking at this table, I can see this hydroxide in my ionic compound. Okay, this hydroxide is insoluble compound. We've got exception if it's combined with group 1 ions or ammonium, it is soluble. But in this case, in our example, OH is combined with copper. Therefore, it is insoluble. Therefore, it is solid. Okay, so we do this comparison for each ion one by one according to this table. Okay, and then we will see that this all is aqueous and only this is soluble sorry, it is solid because it's not soluble. Okay? So the second thing that we have to deal, other than separating the ions, which I've done, I have to write down the charges. Okay, so okay, to do that, we can actually easily refer to periodic table of ions, which I have attached that here as well, which is representing all the charges for all the ions in the periodic table. Very simple, yeah. But we've got a good news that we can actually do a shortcut for some ions. So for ions from group 1 to 8, we can actually memorize this shortcut and we can actually determine the charges. Like group 1 is positive 1, group 2 positive 2, group 3 positive 3, group 4 is 0 only for carbon and silicon. Okay, that means carbon and silicon is not forming ionic bond, they form only covalent bond. So if you refer to this periodic table of ions, group 4, which is here, yeah, as you see, these germanium, tin and lead, they've got their own charges. So please, if you see them in ionic compounds, refer to this table and look into the charges that is here and put the charges. Okay, so the 0 is only for carbon and silicon. So group 5 and 6 and 7 and 8 you can see here. So 8 is not reacting, which is 0. So we've done all that, and this is the complete ionic equation for this example. Okay, and okay, all right. Yes, I forgot to tell you this. Actually, for this table of solubility guidelines and periodic table of ions, simply please Google this title and you would get these tables on the internet. Okay, so the third and the final step is the net ionic equation. Yes, finally. Okay, to write the net ionic equation, we have to remove the ions that are left unchanged and they are actually same on both sides of equation. So what are these ions? These ions are actually called spectator ions. Look at the example. This is the ionic equation, the complete one, yeah, in the previous step. As you see, the SO4 or sulfate, sodium, as you see, they are left unchanged on both sides of the equation. Therefore, I'm gonna remove them, cross them out, because they are spectator ions. So what spectator ion means? It actually means that these ions are just watching the reaction. They're not taking part in any of the reaction. That's why we cross them out. Yes. So this is the end result after crossing these spectator ions out from our complete ionic equation, which is that. So we will get this copper plus hydroxide, which give us copper hydroxide. Okay, and a little note there again, this copper hydroxide is left in the equation because it was a solid, and we proved that by referring to the solubility table and all the things that I've explained. Well, as you've seen in the chemistry, especially chemistry AS level, when you do your practical labs, you do these kind of practicals, and when you see that, you see the copper hydroxide as a precipitate when you actually mixing the two solutions together. So this copper hydroxide is actually a precipitate. Okay. Thank you for listening. I hope you have actually understood everything, and good luck.